Aaron, maybe you could tell us now about the second topic which we have to discuss today, which is constants of nature. What are these constants of nature?
Okay. The thing to realize about these particles is that there's a qualitative component to them and a quantitative component to them. What I mean by that is, let's take an electron. An electron has properties, qualitative properties. Its mass and its charge are the two most important properties for us to think about. So its mass on a qualitative level means that an electron is heavy. You put it on a scale, it weighs something. The charge of an electron tells us that it interacts with light. What you would say in physics, it's subject to the electromagnetic force. Those are two qualities, properties of the electron. Its mass, how big it is, and its charge, that it relates to this electromagnetic force. It interacts with light. But besides these two qualities, there's also quantities. So, for example, how big is its mass? Is it very heavy? Is it light? How much does it weigh when you put it on that scale? And it turns out that that number is actually really small. When you try to put a number on it and measure just how heavy an electron is, you need a really small scale if you want to measure an electron. And that number is 9.1093837.015 times 10 to the minus 31 kilograms.
Let me interrupt, actually, just to simplify things, because that's scientific notation, and Aaron's talking scientific notation. For those of us who may not be that familiar with that, that basically means 0.00000 30 zeros 91093837.015 kilograms. That's the mass of an electron. Carry on, Aaron.
And that's a precise number, exactly measured. Not exactly by putting an electron on a scale, but something akin to that. And it's a precise measured value of the mass of an electron.
That's every single electron. That's why it's called a constant. They're constants of nature. Every single electron weighs that exact amount.
Right. That's a good point. Now, also, when you deal with the charge of an electron, again, the charge of an electron is a constant, where it's always the same for every electron. And the charge measures the strength of the electromagnetic force between two electrons, let's say. So there's a qualitative aspect that two electrons, because they have the same charge, they'll repel each other. Opposite charges attract. So an electron is actually attracted to a nucleus, which is a positive charge. But two electrons are the same charge, and in a qualitative sense, they'll repel each other. But you can ask, how much will they repel each other? How strong will be the force that separates them from each other? And you can measure that. And that's determined by something called the fine structure constant, which is a way of quantifying the charge that every single electron has. And that number is exactly, or again, measured, 137.035999139. Could be there's more decimal places after that. This is how far we've measured it. And that number determines exactly the quantitative strength of the interaction between two electrons, and it's the force, the electromagnetic force.
Don't worry, you're not going to have to remember these numbers. We're just trying to give you a sense of how strange they are. Carrying further with our analogy, we could consider the various pieces of Lego. We might say, what are the weights of these different pieces? The blue pieces may weigh 5 grams. The yellow pieces may weigh 1 gram. The red pieces may weigh 2.374672 grams. And that's the idea of the constants. We have the Lego pieces. The property of them is their weight. That's a qualitative property, but the number which measures their weight is the quantity. That's the first property. But then we could consider another property of these Lego pieces. You might notice, I'm sure you've done this when you play with Lego, certain Lego pieces, if you try to separate them, you could pull them apart very easily. But there are other pieces which you kill your fingers trying to pull them apart and wedging them in between the two. And these are two pieces, usually the smaller ones, but the two pieces connect together very strongly, and it's very hard to pull them apart. In a certain sense, you could consider this as a property of the Lego pieces, how sticky they are, the strength of their sticking together. And that could be seen as an analogy for the charge, how strongly the electrons repel one another.
Or how strongly they bind to a nucleus.
Right.
You know, once you're dealing with Lego pieces, you could also have a quantity which determines just how much it hurts when you step on one of those little pieces.
Ouch. Yes, definitely. That's another quantity. But that's not relevant to our example, so the physics.
No, but it does hurt.
Okay.